We're going to connect an LED to the Raspberry Pi and use Python to control the LED, or in other words, cause the LED to flash on and off based on a Python program. In order to connect our LED to the Raspberry Pi, we're going to take a look at the Raspberry Pi pinout diagram, as you may have seen before. We need to choose a GPIO pin to connect the LED to. I'm going to choose GPIO 26. And we will also need to use a ground pin to connect the other end of our LED to. And for that, I'm going to use this pin right here because it's right beside it, this ground. I'm going to switch over to my webcam now and show you how I've connected this. So as you can see here, GPIO 26, this red wire here, is connected to the positive end of the LED. And then a resistor is connected to the negative side of the LED. And then the blue wire connects the resistor to the ground on the Raspberry Pi, the last pin right here. We use a resistor to limit the current flowing through the LED. If we don't use a resistor, then there's no current limiter in the circuit. Current will flow very quickly through the LED and the LED will burn up. You can tell which side of the LED is negative by looking closely at the shape of the LED. If you look from a top-down view on the LED, you'll see that one side is flat. That is the negative side of the LED. Connect that to the resistor and then that to ground. If you connect an LED backwards, it simply won't work. Now we'll switch back to the Raspberry Pi and write a program to control this LED. Open a terminal and create a new Python file. I'll call it led.py. Whenever we use any of the GPIO pins on the Raspberry Pi, we need to import the GPIO package. So import rpi.gpio as GPIO. We'll also import the time package, which we'll see in a moment. We'll tell the Raspberry Pi that we want to use the BCM pin numbering by saying gpio.setMode gpio.bcm. This means that we'll use 26 as the pin number as opposed to 37. And then we need to set up pin 26 as an output. So to do that, we'll do gpio.setup, pass it the pin number 26, and we want to set it up as a GPIO output. So we type gpio.out. Now we'll create an infinite loop by typing while 1 equals 1. 1 is always equal to 1, so this will create a loop that will never end until we kill the program. At the beginning of the loop, we'll turn the LED on. So we'll type GPIO.output, and this tells the Raspberry Pi that we want to output something to the GPIO pin. We want to output it to pin 26, and we want to output a 1. A 1 means that we turn that pin on. 1 is on, 0 is off. And then we want to turn the LED off. So we'll type GPIO.output. We want to turn pin 26 off. So 26, and then we'll type a 0 for off. And now let's see what happens when we run this program. So save the file, and then type Python led.py. Before I hit enter, I'm going to switch back to my webcam so you can see what happens. So I'm going to press enter in 3, 2, 1, and you can see the LED turns on. But we programmed in the Python code an off command too. So why isn't it turning off? Well, it turns out if we look at the code again, if we reopen this file, this is an endless loop with no pauses in between. So this Raspberry Pi is turning off the LED and on the LED as fast as it possibly can. And our eyes and the camera don't work this fast. So it looks like the LED is just on all the time. In order to make the LED blink, we'll put a pause command in here. So we'll say time.sleep 0.5. And this tells the Raspberry Pi to wait 0.5 seconds between turning the LED on and turning the LED off. We'll put another sleep command after turning it off, so that it's a nice, even flash. I'm going to save and close this file again. And run it by typing Python led.py and hitting enter. And now you can see the LED flashes. And that is how you connect an LED to the Raspberry Pi.